So this is convection. Fluids. Why is my remote not working? Okay, so convection, they say is a transfer of energy in thermal energy in the fluid by the movement of the fluid itself. Fluid just means it's liquid or gas. So that means you transfer energy, thermal energy, because of the movement of the liquid particles or the gaseous particles. So when you heat, when you have the fluid, okay, so the particle that is nearest to the flame will get heated up. So the particle will then rise. So it will move and then it will change its position and then it will eventually goes up. Why it goes up is because of this thing called density. So convection, earlier on we say it's requires movement. So you cannot have solids in the convection process. It only takes place in liquid and gases. Then the reason why this we talked about it already. Then what happens is like this. It gets heated up. So imagine we have a few more, let's say in a layer of so so this is the fluid, the molecules. Then you heat. When you heat this, these particles gain energy, so they will vibrate and they will move. So when they move, right, they will become further away from each other. So from just now, that pattern, it may become further away and become like that, and the rest of the particle probably went somewhere else. So the number of particles here per unit volume decreases. So which means the density decrease. So when density decrease, the ones below here will be lighter. When it becomes lighter, it will go up, it floats. Then other parts of the fluid, there will be some other particles, and all these are not affected by the heat, and then they still remain cold. So the density here is high. So then the density will rush in, the colder particles will rush in to fill up this gap because the particles from the less dense area has moved upwards. So when this so-called process, right, this so-called process is actually just called convection current. And convection current, the process I described just now, is because of the change in density. Then some people will say hot fluid rises and cold fluid sinks. That's what I was describing just now. So the more detailed one is here. So you have the more detailed one here, so you can have a look at this. When it's heated, the distance between particles increase. So volume increase, density drops. Then it will rise. After it rises, the one on top, which is still cold, it has higher density, so it will sink. So then you will get this constant look like that. So we're still at convection. Convection, we have in gases, we have it in liquids. So one highlight is that they may ask you to draw the convection currents in a liquid. So you do need to know the concept of uh, the the fluid is lower density at less lower density will float or rise, then the fluid at higher density will sink. So lower density means it's the ones with fluid at lower density is the warm substance, warm liquid, and then this one at higher density will be the colder liquid. So if you have the very standard question, they'll give you a beaker, then they say they put a color dye inside. So they put color dye here, usually purple or orange. Then they say they will hit here. Then they'll ask you to complete the diagram here. That means the convection current will not be given to you. They'll ask you to draw. So when that happens, you identify that the section where it's heated, on the part where the part of the liquid that is near the dye is heated. So this part, it will become warmer. The liquid will rise. So you'll go up and then you create a vacuum here or empty space here. So when that happens, the colder liquid will, from the top, will sink based on whatever we mentioned on top here, this section. So then you will always have the current in the closed loop like that, which is what is being drawn down here in the diagram. So if they ask you to draw convection current with the dye in the middle and the heating is in the middle, the diagram, the current diagram will look like that. There are also other scenarios, like let's say I draw another one underneath here. Then I have a color dye here at the corner. Then you have the liquid. Then they say heat here. Then how would the convection current look like? So when that happens at the corner here, the hot water here, the water here near here, right, will be warmer, so it will rise. Then like that, right? So you go in this loop, right? Then there will be another situation like this. Then the dye is still here. Then water is here. And then they apply the heat down here. What will happen? Are we going to see a change for this case, the case 2 here? Will there be a change? Will there be a convection current? Notice where I put the heat source. So in the second example of my second question, you will notice that my heat source is on top here. The heat source is here. The heat source is here. So when the heat source is here, the liquid down here in this section will be hot. And because it's at higher temperature, it will continue and try to rise. But it's already at the top, so it cannot rise any further. So water down here will continue to be cold and it will continue to sink. So it will not rise. Because of that, right? Because of the heat, the change in the position of the heat source, in this second case, no convection will take place. Okay? No convection will take place in the second one. I'm gonna go to the next one. So convection in gases also happen in the same way. So you will have hot air, okay, you will have hot gases rising and then the cool, why is this? So the cooler part of the room, right, or the gas, right, then the density will become higher, then you will sink. So it's still the hot air rises, cold air sink. Hot gas rises, cold gas will sink. That thing. So then, so in the room, you will have the circulation of air. So some if the human here, right, the human will expel heat, gases will surround him, will become warm, then you will rise. Then because on top, right, down here, the air is cooler, so it will sink. So convection current will happen in a room like that. And then this is likely a heater. You know, in the winter countries, in cold countries, they will have a heater. Then you will know, you will realize that the heater is always placed under, because underneath, so that the heater will heat up the air below, and then the air will rise and then create this convection current. This is a heater. There's another example later, the aircon. Then the aircon concept is about similar also. So sea breeze and land breeze. Can you explain the sea breeze and land breeze? Okay, I'll just make a quick one. So during the day, we have humans here, we have the land, and then we have the sun. So in the day, the land will heat up faster than the sun. So this side will become hotter. And then the sea is actually cooler. So on top of the air on top of the hotter land, you will just rise. So the air will go up. Then the section of the air above the sea, right, is actually cooler. So because the air here on the land, right, it goes up, it rises, there will be an empty space here. So the cooler air will come in to replace the rising hot air here. So as a person, when you stand on the land, right, during the day, because of this, you will feel air coming into you. You will find that standing down there, you feel the wind. You find that during next to the beach is quite cooling because there's wind coming in, that's because of the formation of the sea breeze. They may ask or they may not ask this depending on the test. So land breeze is the opposite. So at night down here is cooler, the land is cooler, then the sea is warmer. So the air above the sea will rise because it's warm. Then because the air down here on land, right, is cooler, so air will just go out. So then because of the convection current form like that, right, you will have something called land breeze. Okay. So this is whatever I've mentioned just now, the 2 slides before. So you have blue crystals, and then they ask you to heat it. Then after that, then they ask for some, like to draw the convection current, etc. So I don't have to explain this anymore. Okay, this one. So this is a box, and then they make 2 chimneys down here. So then they put in dust particles, you heat, you burn the paper, and then you let the smoke go in. So then you will place a candle here, and you observe that the smoke that goes in will go out from this chimney here. Make a guess, why does this happen? Why does the smoke go out from the chimney here?
Because hot air rises cold air thing.
Mm. So the air on top of the candle is warm, so it will rise, and then it will bring that smoke out, right? Something like that, right? So if you were to write an explanation, this will be how you will write it. So air above the candle is heated and it expands. As a result, the density decrease and rise out of the chimney. So the cooler surrounding air is denser at the other chimney, so it will sink to replace the hot air. Then you will form this thing. Okay, this. What do you think the answer is? Mm-hmm. The other one? Okay, we'll go to the next one. This chapter is full of explanation and long questions and text and all that, so you have to learn how to write. The heating element is at the bottom of the cooker. Soup is heated in a pan on the cooker. Means you have a cooker, a stove, then you put your saucepan on top. Then this stove is part of a thing called the cooker. Then you have soup inside here. Then continue. They also explain. They expect something more. The heating element is at the bottom of the okay. So let's put it as the saucepan, the pan. Then so the soup. So you have to say the soup near the the cooker is heated up, and the it becomes less dense. So the soup becomes less dense and rises. The soup on the top of the, or the soup further away from the bottom of the pan is cold, is cooler, so it's denser. So then you will say that it will sink to replace the the soup that has rice. So thus creating, which is what you wrote down here. So thus creating a convection current. So it goes in 2 to 3 steps, the explanation. So when the soup at the bottom is heated, it becomes less dense and dry. Cold soup at the top being more denser, will sink to the bottom. Convection current is set up in the soup quickly. Something like that. So after you write your hot water rise and hot soup rise and colder but sink, then then you have to say that from your answer you also have to say that the water and the soup under on top of the cooker is hot, is warm, then it's hotter, so it will rise. So that you are short of that. So now you explain why the aircon unit is placed on the top, at the top of the room. Hot air rises and get cold, sinks to the bottom, creating. Can you be more detailed, addressed to the aircon? Add some more details, like how you write such that it looks like it's answering the question. Because now it looks like you are just taking the answer from somewhere and just copy and paste. Edit a little to make it more closer to answering the question. Why hot air rises, the aircon what? So the air conditioner unit, so hot air rises, okay. So the hot air rises, full stop, when the AC unit is placed at the top. It will cool the hot air. Then the cool air, the colder air will now sink, and warm air from the bottom of the room will continue to rise. This sets up a convection current to cool down the room, something like that. So because you have, okay, so you have to say why is it on top. Then when it's on top, what can it do? So that when it's on top, it can cool down the hot air. So the cool down the hot air, you cause the cold air to sink. Then how you get the convection current is when the bottom of the room there's warm air, the warm air will then rise, and this cold air will sink to replace the warm air. So that will cause a convection current to circulate in the room and then be able to cool down the room. So more answering to the question is, this is like a way, whatever I write on here is probably a way I think it would better answer the question. Because if not, your answer, right, it's sometimes choppy or sometimes does not relate to the question. Not that you don't speak to the question. So then they might penalize because they the marker will think that the keywords are not there, or the question, your answer is not answering the question.